Scientists analyzed Vietnamese DNA. It's more complex than any Asian population. When geneticists conducted comprehensive DNA analysis of Vietnamese populations in 2018, they expected to find patterns similar to neighboring Southeast Asian countries. What they discovered instead was the most genetically complex population in Asia. Vietnamese people carry ancestry from at least three major migration waves that arrived thousands of years apart. Ancient Austroasiatic groups who were the first inhabitants. Austronesian seafarers who arrived from island Southeast Asia. Han Chinese populations who migrated south over centuries. These groups mixed in different proportions across northern and southern Vietnam, creating genetic diversity that exceeds every other Asian nation. The complexity is so extreme that genetic tests can distinguish between someone from Hanoi and someone from Ho Chi Minh City with remarkable accuracy. This is the story of how Vietnam became the genetic crossroads of Southeast Asia. Vietnam's genetic complexity begins with geography. The country stretches over 1,600 kilometers from north to south along mainland Southeast Asia's eastern coast. To the north lies China. To the west lie Laos and Cambodia. To the south and east lies the South China Sea, connecting to islands Southeast Asia including Indonesia, Malaysia, and the Philippines. This geographic position placed Vietnam at the intersection of major migration routes. Groups moving south from China passed through Vietnam. Groups moving north from island Southeast Asia reached Vietnam's southern coasts. Groups migrating east from the Southeast Asian mainland settled in Vietnam's central regions. Over thousands of years, these migrations created layers of genetic ancestry that built upon each other. The first layer came from the Austroasiatic peoples. These were the original inhabitants of Southeast Asia, who arrived roughly 40,000 years ago during the last ice age when lower sea levels created land bridges. The Austroasiatic language family includes Vietnamese, Khmer, and Mon. Genetic evidence shows Austroasiatic populations spread across mainland Southeast Asia from southern China to the Malay Peninsula. In Vietnam, archaeological sites show continuous habitation from at least 20,000 years ago. The Ho Chi Minh culture that flourished from 12,000 to 2000 BCE left stone tools and evidence of hunter-gatherer lifestyles. These ancient Austroasiatic peoples formed the genetic foundation of modern Vietnam. The second major wave came from Austronesian seafarers. The Austronesian expansion is one of history's great migration events. Starting around 5,000 years ago from Taiwan, Austronesian-speaking peoples spread across the Pacific and Indian Oceans. They reached the Philippines, Indonesia, Malaysia, Polynesia, and Madagascar. Some Austronesian groups also reached mainland Southeast Asia, including southern Vietnam. Archaeological and genetic evidence shows Austronesian influence in Vietnam's coastal and southern regions, starting around 4,000 years ago. These were maritime peoples with advanced boat building and navigation skills. They brought new agricultural techniques, pottery styles, and cultural practices. The Cham people of southern Vietnam descend partially from these Austronesian migrants. Modern genetic studies show southern Vietnamese populations carry significant Austronesian ancestry, typically 20 to 40% depending on location. The third wave came from the north. Han Chinese expansion southward began over 2,000 years ago and continued for centuries. Chinese dynasties periodically conquered and ruled northern Vietnam. Chinese settlers migrated south seeking land and opportunities. Over time, Han Chinese populations mixed extensively with local Austroasiatic peoples in northern Vietnam. This created populations with mixed ancestry. Genetic studies show northern Vietnamese populations carry substantial Han Chinese ancestry, often 40 to 60%. Southern Vietnamese populations show much less Chinese ancestry, typically 10 to 20%. This north-south genetic gradient is one of Vietnam's most striking features. But the complexity does not stop there. Vietnam also received smaller migration waves from other directions. Thai-speaking peoples from southwestern China and northern Southeast Asia migrated into Vietnam's northwestern highlands. Hmong Mien peoples from southern China settled in Vietnam's mountainous regions. These highland minority groups maintained relatively isolated populations, preserving distinct genetic profiles different from lowland Vietnamese. Today, Vietnam officially recognizes 54 ethnic groups. The Hin, who are ethnic Vietnamese, make up roughly 86% of the population. The remaining 14% consists of dozens of minority groups, each with unique genetic ancestry. When researchers analyzed DNA from across Vietnam, they found the genetic diversity was extraordinary. They collected samples from individuals representing different ethnic groups and different geographic regions. They analyzed both Y chromosome DNA tracing paternal lineages and mitochondrial DNA tracing maternal lineages. They also examined autosomal DNA inherited from both parents, which provides the most comprehensive picture of ancestry. The results revealed patterns more complex than any other Asian population. Northern Vietnamese populations showed genetic profiles dominated by Han Chinese ancestry mixed with Austroasiatic ancestry. The ratio varied, but typically Han Chinese ancestry represented 40 to 60%. This reflects centuries of Chinese migration and mixing. But even within northern Vietnam, variation existed. Populations near the Chinese border showed higher Chinese ancestry. Populations in the Red River Delta showed more balanced mixing. Highland minority groups in the north showed much lower Chinese ancestry, sometimes less than 10%, indicating they avoided mixing with lowland populations. Central Vietnamese populations showed the most balanced mixing. They carried roughly equal proportions of Austroasiatic and Han Chinese ancestry, typically 40 to 50% each, plus smaller amounts of Austronesian ancestry from 5 to 15%. This central region served as a transition zone where all three major ancestry groups overlapped. The genetic diversity in central Vietnam exceeded both northern and southern regions because individuals carried ancestry from all three major sources. Southern Vietnamese populations showed different patterns. Han Chinese ancestry dropped to 10 to 30%. Austroasiatic ancestry increased to 40 to 60%. But the distinguishing feature was substantial Austronesian ancestry, often 20 to 40%. This Austronesian component came from ancient maritime migrations and later mixing with Cham populations, who themselves carried high Austronesian ancestry. Some southern Vietnamese populations, particularly those with Cham heritage, showed over 50% Austronesian ancestry. The genetic profile of southern Vietnam resembled island Southeast Asian populations more than mainland Asian populations. Highland minority groups showed yet another pattern. Groups like the Hmong, Dao, and Muong carried genetic profiles distinct from lowland Vietnamese. They showed lower Han Chinese ancestry and higher preservation of ancient Austroasiatic or Thai-related ancestry. Their relative isolation in mountainous regions protected them from the demographic waves that transformed lowland populations. Genetic studies of these highland groups provide insights into what pre-Han Chinese Southeast Asian populations looked like genetically. The Cham people deserve special attention. The Cham are descendants of the Champa kingdom that ruled central and southern Vietnam from roughly 200 to 1832 CE. The Champa kingdom was heavily influenced by Indian culture and maintained extensive maritime trade networks. Genetic analysis shows Cham people carry a unique mix of Austronesian ancestry from ancient seafarers, Austroasiatic ancestry from mainland Southeast Asia, and smaller amounts of South Asian ancestry from Indian Ocean trade connections. Some studies detect 5 to 10% South Asian genetic ancestry in Cham populations, unique among Vietnamese groups. The Cham genetic profile demonstrates how trade networks created genetic mixing even across vast ocean distances. What if Vietnamese genetic complexity, particularly significant, is that these different ancestry components are not just historical curiosities. They have functional implications. Different ancestral populations evolved in different environments and faced different disease pressures. They developed different genetic adaptations. When these populations mixed in Vietnam, modern Vietnamese inherited a diverse genetic toolkit. This diversity affects everything from disease susceptibility to drug metabolism to physical traits. For example, lactose tolerance varies by ancestry. Han Chinese populations have very low rates of lactose tolerance because dairy was not historically part of their diet. Austroasiatic populations also generally lack lactose tolerance. But some highland minority groups who practice pastoral lifestyles show higher rates. Vietnamese populations show varying lactose tolerance depending on their ancestral mix, with northern Vietnamese showing patterns similar to southern Chinese. Disease susceptibility also varies. Different genetic backgrounds carry different variants affecting risk for conditions like diabetes, heart disease, and certain cancers. Vietnamese populations show disease risk patterns that fall between East Asian patterns typical of China and Southeast Asian patterns typical of Thailand or Indonesia. This makes Vietnamese medical genetics particularly complex. Treatment protocols developed for Chinese populations may not work optimally for Vietnamese patients with high Austronesian ancestry. This is driving research into population-specific medicine in Vietnam. The genetic complexity also has cultural and political implications. Vietnam's history involved conflicts between North and South, including the Vietnam War, which split the country for decades. Some Vietnamese people wondered whether genetic differences between North and South contributed to cultural and political differences. The genetic data shows clear North-South differences, but also shows substantial shared ancestry. All Vietnamese populations, whether northern or southern, carry significant Austroasiatic ancestry linking them to common roots. The differences are matters of degree, not kind. Vietnamese populations are more similar to each other than to populations in neighboring countries despite internal variation. The discovery of Vietnam's exceptional genetic complexity also challenged assumptions about Southeast Asian populations generally. Researchers previously thought Southeast Asian populations were relatively homogeneous, descended primarily from early Austroasiatic groups with some later mixing. The Vietnam data showed this was oversimplified. Southeast Asia was a dynamic region where multiple migration waves from different directions created complex genetic mosaics. Each country has its own specific mixing history, depending on which migration routes passed through its territory. Vietnam's position at the crossroads meant it received more waves from more directions than most neighbors. Scientists analyzed Vietnamese DNA and found it is more complex than any Asian population. This complexity comes from three major migration waves over thousands of years. Austroasiatic peoples were the original inhabitants. Austronesian seafarers arrived from the south bringing maritime culture and mixing especially in coastal and southern regions. Han Chinese populations migrated from the north over centuries, mixing especially in northern regions. These three groups combined in different proportions across Vietnam's geography, creating a north-south genetic gradient. Add dozens of Highland minority groups with their own distinct ancestries and Vietnam becomes the most genetically diverse nation in Asia. This diversity has medical implications, cultural significance, and demonstrates that Vietnam sits at the genetic crossroads of Southeast Asia, where East Asian, mainland Southeast Asian, and island Southeast Asian populations all converged and mixed.